Okay, so you sent over a ton on toxicity testing. And,
Yeah.
just like, how do we even know if stuff is safe to use?
Right.
Whether we're talking about like new drugs
Uh-huh.
or even just like chemicals, like in everyday products.
Yeah.
So I'm ready to dive in. Let's
Okay.
figure this out.
Yeah. So, when we're talking about toxicity testing, you're really talking about figuring out if something is harmful, right? And it's not just for us, it's for the whole environment.
Yeah, like how do they even decide what's safe enough to like
Exactly.
put out there?
Yeah. And it all starts with, understanding how toxic something is.
Right.
And that's where toxicity testing comes in.
So like at the most basic level, what are we even talking about here?
So basically, we need to see how substances affect living things.
Okay.
And there are like different ways to do that.
Okay.
You've got in vitro, which is like in the lab,
Okay.
like literally in glass.
Uh-huh.
And then you've got in vivo, which is using live animals. And the really cool thing is we're even starting to use computers for this, which is in silico. So
Wow.
it's getting really advanced.
That's super interesting. Okay.
Yeah, and all of this is to make sure that things are safe before they're like out in the world.
Right. I mean, it makes sense.
Yeah.
Like you don't want to just start, giving people
Exactly.
medicine or, using chemicals without having some idea
Right.
of what they're going to do.
Yeah, you got to do your homework first.
Yeah, for sure.
Uh,
Okay. So then why are we doing all this testing? Like what are we trying to find out?
So first and foremost, right, we need to know if something is dangerous,
Okay.
but it's more than just a yes or no.
Okay.
We need to know what kind of harm it can cause.
Okay.
So is it acute toxicity, meaning like it's going to hit you right away?
Right.
Or is it chronic, where it builds up over time and then you start seeing problems?
Oh, okay. Interesting.
Yeah. And then we also look for specific things like genotoxicity, which is like, is this thing messing with my DNA? And then we have reproductive toxicity, neurotoxicity, immunotoxicity.
So like the whole gamut.
Yeah, the whole body. Basically, we want to know how it affects everything.
Got it.
And a really important part of all this is figuring out the dose-response relationship.
Okay.
So like, how much of this stuff do you have to be exposed to before you start seeing bad effects?
Right. That makes sense.
And that helps us set those safe limits.
Okay.
And then all this data goes to the regulators and they decide what to do.
Got it. So you mentioned all these different types of tests. Like, where do we even begin with breaking those down?
Well, let's start with the basics, right? Acute toxicity.
Okay.
So this is looking at what happens right after you're exposed to something for a short period of time.
Like immediately.
Yeah, pretty much.
Right.
And you might have heard of LD50.
Yeah.
Which is basically the dose that kills half the animals they tested on.
Oh.
But it's not just about that anymore.
Okay.
We're looking at a bunch of different effects now, like clinical signs and stuff like that.
Okay. So it's gotten a little less,
A little less intense. Yeah.
more nuanced.
Okay, so we're past the immediate effects.
Right.
What happens like when you're exposed to something over and over?
So that's subchronic toxicity testing.
Okay.
We're talking weeks or months of exposure.
Oh, wow. Okay.
And this is where we try to see if any particular organs are being affected. Like, is this thing going to hurt your liver or your kidneys or whatever?
So it's more targeted?
Yeah, exactly. And they give the animals different doses over a long period, and they track like their weight, how they're acting, their blood work, everything.
Okay.
And from that, they figure out the NOAL.
The what?
The NOAL, it's the no observed adverse effect level.
So basically the highest dose that's still safe.
Exactly.
Yeah.
And then there's the LOAEL, which is the lowest dose where you start seeing bad effects.
Okay, that makes sense.
Yeah, so that's subchronic.
And then what about like long-term exposure?
Right, so that's chronic toxicity testing.
Okay.
And these studies can last a really long time, like a year or two even.
Especially when they're looking for cancer-causing stuff.
Okay, so they're looking for like the really long-term effect.
Yeah, exactly. They're looking to see if something causes tumors or other problems down the line.
So they're basically trying to simulate like a lifetime of exposure.
Yeah, pretty much. And they measure a lot of the same things as in the subchronic tests, but they're really focused on those long-term effects.
Okay, that makes sense.
Yeah.
And then you mentioned genotoxicity before.
Right. Genotoxicity, that's a big one.
Yeah, it sounds kind of scary.
It can be because it's all about whether a substance can damage your DNA.
Right, and DNA is like the instruction manual for your body.
Exactly. And if that gets messed up, it can lead to all sorts of problems like cancer or even birth defects that can be passed down to your kids.
Oh, wow.
So they have all these different tests, some in the lab, some in animals, to see if a substance can cause mutations or break chromosomes or other kinds of DNA damage.
Okay, so they're really looking at the potential for long-term harm.
Yeah, absolutely, because DNA damage is serious business.
Okay, and then there's that DART testing you mentioned.
Right. DART stands for Developmental and Reproductive Toxicity.
And what's that all about?
So that's looking at whether a substance can mess with your ability to have healthy babies, basically.
Okay.
So they do these studies in animals where they expose them to the substance during pregnancy or while they're mating or even while they're nursing.
So like all the important stages.
Yeah, and they're looking to see if it causes miscarriages or birth defects or problems with development after the babies are born.
Wow. So like it's pretty comprehensive.
It is, yeah. They want to make sure that a substance isn't going to harm future generations.
Right, that makes sense.
Yeah.
Okay, so we've talked about like general toxicity,
Right.
but what about like specific body systems?
Yeah, so we've got neurotoxicity, which is looking at the nervous system, so your brain,
Yeah.
your spinal cord, all your nerves.
Right.
And then there's immunotoxicity, which is all about the immune system, your body's defenses against disease.
Mm-hmm.
And for both of those, they can do acute, subchronic, or chronic tests, depending on what they're looking for.
Okay, so they're really tailoring the tests to the specific system.
Exactly. And they have all sorts of ways to measure the effects. Like they can look at behavior, they can examine tissues under a microscope, they can even measure electrical activity in the brain.
Wow, that's amazing.
Yeah, it's pretty incredible. And on top of all that, there are even more specialized tests for other organs, like the liver, the kidneys, the heart, the endocrine system, which is all about hormones.
So like everything gets looked at?
Pretty much, yeah, they really try to cover all the bases.
So is all this testing like a legal requirement?
Oh, yeah, absolutely. The FDA, the EPA, the EMA, they all have very strict rules about toxicity testing for pretty much anything that's going to be sold to the public.
Wow.
Yeah, and the specific tests that are required depend on the product and how people are going to be exposed to it.
Okay.
And a lot of times they start with the simpler tests, like the in vitro stuff, and then if they see any red flags, they move on to the more complex in vivo studies.
So it's kind of like a tiered approach.
Yeah, exactly. They don't want to jump to the most expensive and time-consuming tests unless they absolutely have to.
Right. That makes sense.
And all of this data goes to the regulators, and they use it to decide if a product is safe, how much of it people can be exposed to, and what kind of warning labels it needs.
So it's really all about protecting people.
Exactly. It's about making sure that the things we use every day aren't going to harm us or the environment.
Okay, so if we had to sum up like the one big takeaway from all of this, what would it be?
I think it would be that toxicity testing is a really complex and incredibly important process.
Okay.
It involves a whole bunch of different scientific methods, and it's all about making sure that the things we're exposed to are safe.
Yeah, it really makes you appreciate all the work that goes on behind the scenes.
Right, like we don't even think about it, but there are so many people working to keep us safe.
Totally. And it makes you wonder, like, as science keeps advancing, how are these tests going to change in the future?
Oh, yeah, that's a great question.
Thanks for breaking all this down. It's been super interesting.
Of course, anytime.
All right, well, that's our deep dive for today. See you next time.
See ya.
Bye.